Good morning, everyone. My name is Jaini, and today I'm going to present my topic of project, which is AI-based network intrusion detection system. In this project, we have used Snort for the packet analysis, Python, and logistic regression model for the intelligent threat detection, and a Flask-based UI web page which offers user-friendly interaction. Okay, so first we will see what is NIDS, Network Intrusion Detection System. It monitors network traffic and identifies suspicious activity among the network traffic in which traditional NIDS often lack adaptability. So we are here upgrading our project and using AI-based network intrusion detection system. Here, there are three mentioned problems of cybersecurity. The first one is increasing threats. Cybersecurity threats have become more frequent now, and the attacks are growing sophisticated and targeting vulnerabilities. The second one is manual inefficiency. Manual, manual detection methods struggle to keep pace, and they rely on signatures and missing new threats. The third one is need for AI. So here we need AI-based solution for our real-time detection of threats so that it provides a robust security. Here, my project, which is AI-based network intrusion detection system, has three major objectives. The first one is SNOT implementation. SNOT is an open source network intrusion detection software which configures and captures our network traffic and alerts the users. SNOT is a detection software, so it doesn't prevent the attack, but it can generate an alert to the customer, and then we can prevent it through any other way. The second major objective is AI model training. First, we have configured Snot in our VMware and capture that logs from a VMware into a Jupyter notebook, and then we have trained a model which is logistic regression for better accuracy. And then we have used that snot logs and also trained our dataset through NSL-KDD for training our logistic regression model. And the last one is Flask UI. After this training and capturing of network traffic and attacks, we have finally made a web page for a normal user interface so that a non-technical user can also go through this, and it can be used in a cybersecurity portal for capturing traffics and networks. The overall technology stack is here given of my project. The first one is backend. In backend, we have used Python and Flask. The second one is NIDS. For NIDS, we have used Snort. As I earlier mentioned, Snort is an open source intrusion detection software. So I have used Snort. The third one is machine learning. After running and testing Snorts through Kali Linux, we have performed and trained my model for network intrusion detection system, which can be more efficient in cybersecurity domain uh, by making the detection software AI based. The fourth one is deployment. Deployment is still pending. It is my future scope of deploying my website in AWS Lambda. And the fifth one is virtualization, where I have used VMware. VMware, I have configured Kali Linux, which is the attacker, and the Ubuntu. In Ubuntu, I have installed Snort, so it captures traffic and detects the user where the traffic is intrusion. Okay, so here I have used Snort in basically three ways. As I earlier mentioned, Snort is an open source NIDS. So the first one is packet analysis. Snort analyzes the network packets in real time. It uses the rule-based detection to identify malicious activity. The second one is log generation. After the packet analysis is done, we have generated that Snort packet logs into detailed ones of detected events, and then we have used that logs into our AI model training and analysis. So for that logs, we have to convert first them into CSV files. So which is CSV files are suitable for training our models in Python. So we have converted our snot logs to CSV file. There are two data sets used for training my AI model, which is logistic regression model. So the first one is synthetic data set. Where that synthetic data set comes from, it is where the first time I mentioned earlier, where the packet analysis, after that, we have converted that packet analysis into logs for training our model, and that logs are converted into CSV format. So that CSV format becomes a synthetic data set. And after training our synthetic data set, we have also trained our logistic regression model in through NSL-KDD data set, which is a pre-existing data set of network attacks. It is used for comprehensive training and validation of AI model. As I mentioned earlier, we have used logistic regression model for our project. So the first one is algorithm, which is logistic regression model. And this model is used for binary classification that predicts whether a network packet is malicious or benign. The second one is feature scaling and hyperparameter tuning. The algorithm and the model is already trained, but for improving the accuracy, feature score, FN score, recall capacity of the model, overall, for improving the model accuracy, we have to perform feature scaling and hyperparameter tuning, which optimize our model settings and model performance. So it ensures all features contribute equally to our learning process and which results into a better and efficient model training. Logistic regression model, which we have trained, has this overall evaluation metrics, which I will show here. The first one is 95% accuracy we have achieved through hyperparameter tuning, which is the overall correctness of the model. The second one is 92% of precision. Precision is the ability to avoid false positives. The third one is 94% of recall. Recall is the ability to detect all possible and actual positives in our training and network dataset. The last one is 93% of F1 score, which is the harmonic mean of precision and recall. Here I have presented the system architecture flowchart, which tells us the overall flow of our project, which is AI-based network intrusion detection system. So the first one is snort logs. Snort generates network traffic logs. The second one is data pre-processing. The snort logs generated are converted into CSV formats, and they are used for data pre-processing. The logs are processed and converted into CSV there. The third one is AI model. In AI model, we have trained our AI model which predicts intrusion, and we have used a logistic regression for that. The last one and fifth one is intrusion detection. The system detects and alerts on intrusions. So it as it is a detection software, so it doesn't prevent the attack, but it can just inform the user that it is an attack. So we can prevent our data. And the last one, we have created a web page using Flask and Python to provide real-time user interface. Here are the implementation steps of my project. The first one is install and configure Snort, which is done in VMware, on which I have Ubuntu. In VMware, I have installed and configured my Ubuntu system, in which Ubuntu I have installed Snort, and through this Snort, we are capturing our network traffic. The second one is generate and extract logs. Uh, Using Snort, we are generating the logs of every network activity so that we can detect if even if the network is intruded or not. The third one is convert logs to CSV. For making our project AI based, we have to train the model, and for that, for training the model, we have to convert the snort logs into CSV format. So we are converting that into CSV format using data pre-processing. Then we are training the model, and at last we have developed the UI, which will be showed in further slides. And at last we have to deploy a total website on AWS Lambda. This is the UI demonstration, and it is the main page of my website, in which it shows and mentions the overall 20 features. And then we have also here constant normal and intrusion traffic to test and analyze our traffic, in which here we have loaded the intrusion sample and it is detecting correctly that it is an intrusion network traffic. So there are the key features. User-friendly interface. It provides using Flask. It provides real-time intrusion detection, and there is detailed log analysis through Snort. This slide demonstrates the building of Flask API. Here we have built the API endpoint, which is slash predict, which predicts the network traffic, whether it is an intrusion or a network or a normal network traffic. The second one is trained model. It is integrated all over Flask API is integrated to our AI model so that it can detect as efficiently, and the third one is API. So we have created a simple and secure API endpoint through Flask. These are some of the website images I have shown here. The first page, it is about NIDS. There are mainly only two pages. So this is the second part of my website, which describes about my project in a brief manner. The second one is showing the feature scaling graph, where we have trained in Jupyter Notebook, the logistic regression. So it is the feature scaling graph of this model. And the third one is network traffic features, where we have loaded a normal traffic and it is detecting correctly that it is a normal traffic. This was the last step in our development stack of the project, which was deploying our website on AWS Lambda. So we have to deploy the backend, which is Python and Flask. So that files are can be deployed in Lambda function using AWS, and the UI pages are deployed on Vercel or Netlify. So using that Vercel and AWS Lambda, we have to connect both of them so they can work efficiently, and we have to connect them to that live API so that it can send the live network traffic data, and we can detect our intrusion or normal traffic as efficiently as possible. So these were the challenges and troubleshooting which I experienced when I was making this project. The first one is not log format, which resolved issues using format incompatibilities. It took a lot of time for me to do that. The second one is data pre-processing. It overcame data processing challenges. And the third one is model tuning, where we have to improve our model efficiency through hyperparameter tuning and feature scaling. So that difficulties created a lot of big impact. So these were the total results and findings after the overall project is completed. There is total 95% accuracy, which the AI model, that is logistic regression, we have used. It detects the intrusions with a very high accuracy, which is 95%, and there is total 80% of reduced false positives, which improved our accuracy with feature engineering. These are the future enhancement of my project. The first one is deep learning. After performing and making our project AI based through machine learning model, we will further add the deep learning models for better accuracy. The second one is real-time monitoring. We will develop a real-time network intrusion detection dashboard. And the last one is threat intelligence, where we can enhance our system with threat intelligence field. So this is the final conclusion of our project. The AI-powered network intrusion detection system. It significantly enhances the cybersecurity. Snort and AI combinedly create an effective intrusion detection system. It offers real-time detection, scalability, and a very improved accuracy, which I have earlier seen that was 95%. Thank you.